Right, everyone, I think we are ready to get settled down again. So if you'd like to come and take a seat and get ready for the next talk. So Jeremy will be giving some in-depth info on Crux in Crux 101, and then we'll hopefully get our hands dirty with a bit of workshop. There are some seats at the front. Guys at the back, don't be afraid. Feel free to move down to the front. I don't think anyone is. Okay, right, and I'll hand over to Jeremy.
Thank you, Susan. So does it still count as subliminal messaging if I point it out? I don't know. No, it doesn't. Okay. How's that clicker? Oh, that's John's slide. I have to go back. There you go. Crux 101. So yeah, I hope that was a good introduction. I thought it was very good. I haven't actually seen John do that presentation before. He did present something a bit similar in Closure North. I don't know. Hands up if anyone saw that video in Closure North. It's out there. It's on YouTube. But he did a great job. I'm very glad he's got that out of the way. Now I can just talk about the fluffy stuff that Crux also happens to do. So Crux 101, what is Crux? So if you've seen the homepage, you'll know it's an open time store, and maybe you've read some more details. But I think this concept of an open time store is very important. We spent a lot of time thinking about those three words, and if we had to pick three, what would they be? Open is, of course, a really big one because it's open source. But actually, open has huge other implications. You know, we're very open with the community. We sort of want to take everyone's feedback. We're open in the sense of Crux is a document database. So it takes documents, and that's important because it's open to change. And the bitemporality means you're open to changing query requirements. So you're never having to think, oh, I really wish I implemented these bitemporal tables, 3 years ago, because it's there. You didn't have to think about it. So you're keeping your options open. Of course, it's time, and it's a database. So it's a primary store of data. And how it does that, we'll walk through. But really, it is a database. It's not just Susan and I were just talking about Kafka streams. It's not just a materialized view of another data source, although it could be. So if we just step through this list, we'll talk through these. So open source is obviously a big thing. We're very passionate about making sure that Crux is as successful as it possibly can be, and that's why we chose the MIT license. Maybe we'll tweak that or something, but fundamentally, Crux is always going to be an open source thing that we do, and that's something we all feel quite passionate about as individuals, and we think we can make this work as a long-term supported product. We'll come to that. So what I'm going to do now is just step through these points with some visuals. So what does unbundled mean? Has anyone seen the Martin Kleppmann talk about the Unbundled database and or read the blog? Show of hands. Quite a few people. So not everyone. Okay, so a lot of people I know will be familiar with other things, immutable logs, materialized views. They're all kind of the same deal. But in particular, what was novel about the Unbundled design that Martin Kleppmann highlighted is the way that Kafka, obviously his is heavily involved in Kafka. Kafka is sort of central to this log streaming architecture. If you put it in Kafka, it can be read by someone else at some future point in time. And all that matters really is the ordering in those topics in the Kafka logs. So we use Kafka heavily to sort of solve this, how do you run transactions in Crux? So we take transactions in through the Crux API, and the first thing that happens is it goes in the log, because that's what being unbundled means. It means that potentially you could have other things other than Crux reading from that log, inferring things. Maybe you have a completely different implementation of Crux reading from that log. And so once the transaction is on the log, it gets sort of split into two logs, actually, transaction log and a document log. Transaction log is serial, so it's fully in order, linearized. And then each of the Crux nodes picks up the transactions and the documents and ingests them. And it's only at that point that actually your transaction is either sort of, a valid transaction that worked and was, accepted into the index, or you find out that the transaction failed. So you can retry. And of course, we have things like compare and swap to make that possible. But what's interesting about being unbundled is that we're able to plug and play these components. So Kafka does this thing really well, does it at scale, and makes it work really nicely across a small region of data centers. Maybe you don't want to do a big globally distributed Kafka implementation because you'll have more severe latency, but we could maybe put some Calvin magic in there to make something bigger. Or we could actually just not use Kafka. It's quite a heavyweight dependency. Maybe you just want to get started quickly. So we can change what that is. And equally inside of Crux, we have two options for the key value store technology that underpins the document and the bitemporal graph index structures. So either RocksDB or LMDB. And these have sort of different trade-offs and proven to different sort of scale, but certainly RocksDB is, I heard someone mention it was a petabyte sort of scale thing these days, which is seriously impressive. But as your needs change, you can swap out the components. And that's another important thing about being unbundled, is because you can change things. As long as the log is consistent, you can change all the things that are processing that log at any future point in time. And that's why we have multiple Crux nodes, each reading from the same logs. And the Crux nodes are fully sort of independent from each other. They're not, not coordinating between them. That's the current architecture, at least. So that's what Unbundled is. Very brief tour. John has described this. So the language we could use with describing inserting into the past is retroactive, and into the future is proactive. So these are operations. So whether you're doing a put or a delete or an evict, you can assign time coordinates to those things. So in the valid time, I want at the end of a transaction, you can put in the time that you want that thing to happen. So, and that makes it a retroactive or a proactive operation. And then with the queries, we talked about as of earlier. The language as at is also quite useful. So you can either, most of the time you'd be wanting to query the valid time, but you can also do valid time and transaction time to do those sort of audit queries. And that capability is what gives consistent reads. So as you have multiple Crux nodes, you know that they're at the same transaction time level by querying, by specifying the as of time. And that's what allows you to scale and know when the nodes are up to date, and you can put them behind a load balancer or whatever you need to. So bitemporality is of course really important. I won't labor that too much. But what's really interesting, and I'm really excited about in a way, because I was a bit daunted when I thought, oh gosh, I'm going to have to set up, even the embedded Kafka mode still feels quite heavyweight. It takes a good 30 seconds to spin up the embedded Kafka. What's really nice now is that you can just run it in a jar. It's just another library. It's just another innocent closure-like library running in your jar application, and writes to the file system. So that's one mode of using Crux. Now, clearly, you're not going to want to run your entire business on a single instance, and you're going to want that resilience to do that sort of Kafka model on the bottom right-hand corner. But you certainly have various options for how you scale and where you actually build your application. Do you want to embed Crux inside your application, or do you want it to be standalone to sort of maintain that separation? People are using Clojure. I think it's quite a no-brainer, but for other languages, other ecosystems where you really just want to use Crux as an API, we have that HTTP API to make that happen. So lots of options there. So embedable's quite big. But then, as I say, Kafka, it's a big deal, and we trust it. We think you should trust it as the golden store of data. It makes a very effective way of scaling applications and the database. And so whilst I wouldn't say Kafka is the database, Kafka is the golden store. And the Kafka team, the Confluent team, have written at length about why that's a viable strategy. However, people may say, well, I want to use Postgres anyway. Well, it's unbundled. So you can actually just build a JDBC driver and use Postgres if that's what your organization needs. But the point is that Crux was designed to work at this Kafka level of scale, even if you don't need to use it. And that is really important for things like the being document oriented. So if you have this huge scalable database like on John's slide, where you have messages coming from all over the world, you can't guarantee the schema. You don't really want to enforce the schema on that. And that's, again, why Crux is built in a schemaless model because it's all about scale and maybe the scalability of the teams and the systems connecting into Crux. And of course, we have the HTTP interface, which makes it scalable in other ways in terms of cacheability. Data log. So my backstory, I appreciate I didn't really explain my backstory. I've been with Jux since January. Yeah, January. So not too long. But my story with Clojure is about 4 or 5 years old now. But what really attracted me to Clojure was data log. I saw the power of Datomic and DataScript, and I was just like, that's awesome. That's what I want. That's how I want to model my data. And if Clojure is the best language for using data log, then so be it. So that's always what's attracted me. And this data log model of managing data just seems brilliant, in my opinion. And the way we've implemented it in Crux enables you to query across documents. So we have this document model, which is essentially just a map, an Eden map. And you're able to run queries across the different attributes, the top level fields in those maps. And they're all sort of automatically connected together. And you can run very generic graph queries and algorithms. And we've got some examples like that in the repository. Also, you can use full data log rules and your own sort of custom namespaced Clojure functions, whatever's available. So right now, you can put anything you want in a data log query and it will run. And then the other really interesting thing about our data log implementation is that we support result sets, but we also support seeks. So that means it's lazy. So you don't have to retrieve the entire data set at once. And also we can spill out onto disk as well. So we've had this sort of laziness in mind. So again, very, very impressive stuff. We can talk more about that. Did I skip one? No. So another thing that we've gone into this eyes wide open thinking about is eviction. So we have the 4 key operations. Eviction is, there, very front and center. And the reason for that is that's what businesses are demanding. And we wanted to make that sort of a primary focus. If we can get that, if we can nail that, then no one has to worry about it ever again. Now, clearly, you can't just say, oh, we've got eviction and therefore we are GDPR compliant. But it's a good step to getting towards having this database platform that does all of the compliance type things you need. It's a primitive. So clearly that's very useful, and you can do things like evict over a time range. So you can say, well, the document that contains some sensitive information that we should probably delete is somewhere in this range, or maybe there's multiple versions. We will just delete that range, and you can do that, and it will update the Kafka log, delete it from the document. That's why you have 2 logs, and it will go to each of the nodes and delete the indexes in the nodes, so that the nodes are, when they read in the evict transaction, they delete their own indexes. So it's a very important functionality, and importantly, it has a nominal performance impact. So when you do an eviction, you're actually sort of putting a tombstone in there, which means the performance is sort of negligible. You're not having to rebuild any funky index stuff. So in summary, open source, unbundled, bitemporal, embeddable, built for scale, data log, GDPR friendly. And as I said at the start, it's supported. This is something we're pushing as a product. We want to provide this in a way that you can take confidently into your projects, knowing that Jux has your back, which I think is a really important point. So we'll have possibly just maybe any questions at this point, not a break because we just had a break. So does anyone have any questions on that stuff before we go into the hands-on? Hey. Oh yeah, that one. There might be a bit of feedback with that.
Thoughts on the question? Okay, you go.
Yeah, whoa. I just wanted to ask about eviction, and this might be my me not understanding how the document model works compared to Datomic. That's what I'm thinking of. But so I'm comparing the documents to entities in Datomic. So if, as part of the transaction, I update 2 documents, and then I want to delete some information that related to one, but not the other, am I deleting a transaction, or am I? Yeah.
You're just deleting a document. So a transaction might contain multiple documents. Yeah, we'll pass this around. or just shout. Yeah, so a document might contain, a transaction might contain multiple operations, including putting multiple documents. But that's eviction only operates at the document level. Yeah. Repeat the question. That's a good tip. Okay. Yes. Any other questions? Hello. Event sourcing. So it's a good question. So I would say that yes. The question is, how does it compare to event sourcing? So event sourcing implies events. So in the transaction log that Crux has, you're putting transaction commands. So there's also this concept of command sourcing. So there's a little bit of nuance there. But fundamentally, Crux is implemented itself as an event source database. So that transaction log is immutable. You'll never rewrite the transaction log. The document log, however, you can evict documents. So technically, you're going to have to make your business logic accept that some documents may go missing over time. But the event sourcing model fundamentally is implemented within Crux. That's not to say you couldn't implement event sourcing in your application layer on top of Crux. So if you wanted to use valid time to model events and then create some other kind of consumer which consume the valid time sequence of events from Crux, then that's another way you could do event sourcing. I don't know if that answers the question enough. I do have quite a lot of thoughts about this, so if you want to talk, and we can do it, maybe a QA panel question. That was a good one for the panel. Okay, anything else? Hello? Oh, if you did.
What was the use case in Jux that made you build Crux?
Yep, so about 2.5, 3 years ago, Jux had the exact problem that John described with systems all over the world that needed to flow into a global message bus and be interpreted by the business. So essentially this use case where you've got out of order ingestion at a system level. So you're using Crux almost as an integration technology for multiple systems and get a consistent view across those systems. Yeah, with all the auditing and things. So it is quite a specific use case, but the whole thing has been shaped by Jux's wider experiences, working on that project, working on, we're heavy users of Datomic, obviously we're familiar with that. We've spent a lot of time reading academic papers and stuff, finding out exactly what's important by temporality. So there's been a lot of things going into that, but that's certainly the primary use case. What was the other question?
Yeah, I just want to know,
So is Crux production ready? So we are not using Crux in production with a customer. It is on our website right now, so it's powering some limited functionality on the website. So it is still very much alpha. When we have a production customer, that will be the point at which we go into beta, or when we have a customer who is about to go into production, we'll enter formal beta. So that's the sort of indicator. But yeah, right now it's still in alpha. Yeah, how far away is it from being production ready? It's a good question. So we have some features we think we want to add just in terms of ergonomics, making it slightly nicer. But in terms of the low level, does it store data consistently, and does it allow you to read things consistently, correctly? I think we're in a pretty good shape. We still want to do more performance testing, but we think we've got a lot of tests, and if you look at the test folder, there's all kinds of tests from we've adapted like Sparkle test suites for RDF, which really stress test the graph query language, and we've got all kinds of tests for if you really mess up the Kafka instance or something, how does it replay? Does it replay correctly? And for that embedded mode I mentioned as well, we've got some tests around that just to make sure that works, including backup and restore for embedded mode. So it is production ready in my opinion, but I think until we have a customer, we can't formally say that. Yeah. Good question. Is the transaction log format stable? I would say we made a change last Thursday, wasn't it? So until last Thursday, you had to specify the ID in the transaction and inside the map, and we just changed it, so you just have to specify it once. So that is a breaking change in the transaction log. Yeah, to be honest, these four transactions are so fundamental, and all you have is you put a map after it, and maybe you specify a valid time, and that's it. Like those are the four operations. I don't think that's going to change. Maybe Håkan, maybe you have a perspective, but we can come back to that in the panel. I'll make a note. But I think it's stable, unless someone spots a major flaw. What we might do though is add extra operations, like transaction functions, for instance. Good question. So let me go to the unbundled slide. So Jepson is really designed for distributed databases. Now, there is an argument that actually Crux isn't a distributed database in the sense of, well, the transaction log is a single linear order, and we're not doing any clever consensus algorithms. So Kafka definitely, I think it has Jepson tests, and that should be Jepson tested. But what Crux is doing is so simple that it doesn't need Jepson testing. Or, well, I mean, maybe there are things that test we can apply to, but fundamentally, it's not trying to solve a distributed problem. And the queries are all within the node. It's not like multiple nodes are collaborating to answer questions. Good question. Okay, anything else? Let me just go to 20. All right, so in that case, I will commence a little tour of some things we've been building, which hopefully give you a flavor. Hopefully this mic stand will stay in place. Excuse the shadow. Okay, so here, right. Has anyone looked at the repository? So you may have noticed there is good. You may have noticed there's an examples folder with various things in there, and we're just over time putting things in there. We do have other things elsewhere, so I'll just give you a quick tour around where they are. But for this one, for instance, this is like the most simple sort of thing you could do. It's a very short whirlwind tour through the transaction commands. So I'm going to take you through this, and what we'll do is look through some examples, and then I'll give you a chance to play around. But first of all, I'm just going to run these commands. So you can specify using tools depths to run it with the Crux dependency, which is handy. And I'm just going to copy and paste as freely as I wish into the REPL. So you'll notice, you specify Crux dependency. You can import the Java type as well if you want. So Crux supports various different modes. As I said, you can use Kafka, you can not use Kafka. This is actually not even using any persistence. So memkv is our key value in memory way of storing the logs. And actually, it's not even actually using the event log directory. But if you want to do a backup, you can actually back up this in-memory thing to your disk, which is quite nice. So if we start the standalone system, so standalone is the mode where we just use it without Kafka. So that looks like it's active. So we're going to submit our very first transaction, which may actually be the very first time transactions being submitted on stage anywhere in the world. There you go. So you can see it's returned a couple of bits of information. So one is the TXID, which essentially is the Kafka offset. Now, in case you're wondering, we use a single, we're not using Kafka here though, but we use a single Kafka topic with one partition for the transaction log. So that's always a monotonically increasing number. But yeah, as I said, this is in memory. So that's what that number is. And then for the TX time, that's the timestamp as recorded by the thing recording the transaction. So actually, in the Kafka use case, that would be coming from, I appreciate not everyone can see this actually, just move up here. That would be coming from Kafka, like Kafka timestamps that transaction and then returns it back. And you may have noticed the data we're transacting is a put operation. So it's information about Pablo Picasso. He was born in Spain at this valid time. So this information has now been inserted into the past. So if we try and find out when Picasso was born, as at whenever it would be, 1880, as in the year, then you wouldn't find a record for him because he just doesn't exist. So you can simulate that. So we're just going to add a couple more transactions. So that was a put. This one is a CAS, so compare and swap. And what that is going to do is going to take two documents. You could also use the hash of the document. And it's going to compare, is that old version valid at the point I specify? And you're actually specifying a time down here. You don't have to specify the time. It could just be in reference to the current valid time, because by default, valid time defaults to transaction time. They're the same unless you specify otherwise. And then you're saying, well, if it's this old version, then I'll insert this new version. But if it's not, then fail the CAS. That's how CAS works. So we can run that. And I think what this does, what did I change? I added height, that's right. So now we know how tall he is. Yep, which is good. And then we can submit a delete operation. So delete, what delete does is it takes an ID, in which case is, we've got this sort of almost, it's like a URI kind of thing, but translated to a keyword. And we're deleting it from the valid time timeline. So what that means in a bituple context is we're not actually deleting it at all. We're just deleting it from the view of the database at that valid time and onwards. So if we actually want to, we can always go back to the previous transaction time, or maybe to the earlier time before that to see, well, what was the value. So it's not really deleting it, it's just deleting it from the business point of view, the application point of view. So that's worked. And we know this worked because if it hadn't worked, we wouldn't be getting new transactions. So the transactions are submitted, but until now, we don't actually know that the ingestion has happened, the indexing's happened. It's not until we start to query that we figure that out. And I'll just do the final transaction, which is to evict. So I can pick start date and end date and decide whether I want to keep the latest, keep the earliest, and submit that as well, just to prove full eviction. And the implication now is that when I query this data log query, as of now, I'm not specifying a time coordinate. I don't see any document. And that's because we just evicted it and also deleted it. But if we use a previous time, such as 1973, which is the year he died, we can see that actually we do still have that document. And then we can always put a new version of the document and then query again as of system time. But you get the idea. So we're just running through this walkthrough CLJ, putting, casing, deleting, evicting, using the 4 operations and running a query. So that's kind of interesting. And I'll let you sort of do that at your own pace if you want to try that. But I had some other examples I want to show you. So I'm just going to go back to the deck. The first one is a message board app. Now, anyone that was part of our advisory group before we launched at Closure North will have seen this. Was anyone there? Or did anyone watch the webinars? Maybe? Andrew at the back, great. Yeah, so we had a few demos sort of working in progress to try and demonstrate things. And one was this app, which demonstrates some of the concepts quite nicely. So I'm just going to take you to have a look at that now. So it's actually hosted at demo.crux.cloud. And this is a live version of the app. So right now, this green bar shows what the time now is. It says now there. And you'll see that there's been a few transactions today. So we'll look at the transaction time axis here, and we can see that there's been some transactions this afternoon. That was me. And I made a transaction about 15 minutes ago. Or no, an hour ago, something like that. And then there's actually another thing up here. So if we click on this, what we'll actually see is that I made a transaction this afternoon about something that happens in valid time in the future. And there's some spams in there as well, which is great. So what we can do is use this to view valid time and transaction time quite neatly. And this is live, but we won't worry too much about trying to add data to it because we've got better demos. But it does have this nice timeline graph. So it shows the the valid time, transaction time in 2 dimensions, and then you can see exactly what that transaction was and the documents it affected, and click through the documents and then sort of navigate through the graph as it was at various points. So pretty wacky, does lots of stuff, but it's a good way of explaining some of the fundamental concepts. So that was the first thing. Then since then, for the launch, we did this bitemporal tail. Ivan wasn't able to join us. He's still in Moscow, but he has been working hard today. And I pushed that out last week. So we're just going to have a quick tour through these. Has anyone tried to use these already? Anyone looked at them? So I'm actually using NextJournal for these. So NextJournal was announced, or maybe it's been out for a while, but there was a big Hacker News thing like 4 weeks ago, and I thought that looks awesome. I'm going to try and do Crux tutorials in NextJournal. So that's where those examples are. So we'll just move across to those. So one was, this bitemporal tail, which is quite a nice little short story, walking through some similar setup. And here we're submitting information about some kind of Dungeons and Dragons character or something. But no, it's a guy who's in 1740. He has some possessions. He lives in some place, and we're adding information to the story. We're elaborating a story, and over the course of this journal, next journal entry, this notebook, we're elaborating on what happens and when it happens. So it's quite a good way of getting you sort of thinking about the problem space without being all about finance or something like that, which is nice. So this does take you through most things, and we can the way NextJournal works is I can actually step through it very easily. So if I press edit, I could also press remix, which allows you to clone this and then like make your own changes. But it's executing closure on their servers, so I don't actually have to have anything on my laptop. I don't have to have Line or closure installed, just the browser, and I can step through these one by one using Shift Enter and define this. So if I define the system, when that goes green and the system is defined, should be defined. Oh, it's still flashing. Is it still going? I don't know if the connection's dead. Let's just try putting a submission. So you can see we've got some data from the last time I ran it, sorry. But you can rerun the queries, and NextJournal just gives you this ability to view the inputs and outputs. So here we can see we're submitting some more characters and some items: forbidden beans, pirate sword, flintlock pistol, and putting those things sort of together in a little graph. And you can see we're specifying IDs using keywords, and then we're saying, well, this location is within this other location. So we're just freely within those documents saying that this attribute is pointing to this other document by virtue of sharing this ID, but we're not having to define that anywhere. So you'll note that there's no having to think about your schema up front. Obviously it helps, but you don't have to define it. So then we can define the DB, and then we can start running queries and say, well, here's a set. What's in that set? Oh, we've got Charles, and we can find out more information about Charles. So this is one example. The other example, which I mentioned, was graphing with Crux. So this is something from the Neo4j originally, the Neo4j cookbook. So they have a little explanation in there about what this data set is, and it's a bit convoluted and a bit abstract, but it's the concept of hyperedges, which basically means that you're modeling your graph using nodes to represent edges, so you're actually connecting things within that graph at a sort of meta level, which isn't necessarily like what you're going to do straight away, but there are benefits of doing this, and at a high level it makes sense to do this. And one of the things we're actually looking at doing with Crux is to take your document, break it apart into a subgraph, and put it into something like this, so that you can query very easily. But so anyway, so this example has users, it has groups, and it has roles, and all three of these. So a user can be part of multiple groups, and they can have multiple roles in those groups. Roles being, I'm the administrator or the secretary or the account keeper or something like that. And so each of these roles and groups and users form a graph, and they have a example of the full graph. So this graph here is the data which we look at in a moment. So if we go back to graphing with Crux, you'll see it's got basically the same setup as before. We define the system, it's in memory. Some note here about how to enable it with rocks, which is very simple. And then we have the graph, and the graph itself is, well, that's it. So it's a very short definition. It's got a little bit of decoration there to add the ID. So you're pulling it out of the document and then adding it as a Crux, crux.db/ID key, searching it into each of the documents in that vector. But essentially that vector is all the documents I would need for this example, and I submit it in a single transaction. So sort of conceptually, this isn't very interesting from a transactional point of view, but from a data log point of view, it does get interesting because we're saying, well, transaction succeeded. I should then be able to use that database value and query using data log some interesting things like finding roles for users and particular groups. So so for a given user, show me all of their roles. So quick show of hands, who has a good understanding of data log, or shall I do an explainer? I mean, it doesn't have to be a top. So there's a great website called learndatalogtoday.org, which uses a very similar sort of data log setup like this. But it is a very good intro. I'm not going to necessarily go too deep into data log if no one has too much experience. It'll probably take a little bit of time. But essentially, it's pattern matching. It's saying that where you have these clauses, it's joining across all these clauses and looking for things that fit that shape. It's declarative query because you're saying this is the data I want, go figure out how to get it. And it's then Crux's job to go through all the combinations that are possible in the database and find a solution to that. And then it uses arguments or rules or functions to produce the result set. So here we have role name. So that's the only thing we actually care about. And that's what we're picking out here. The role name is role name 2 or role name 3. So this query here is taking in user 1. It's saying, show me all the groups that user has a role in. Then for each of those groups, get me the role name and the group name, or just the role name, sorry. And then for each of those roles, get me the role names. It's doing this sort of recursive lookup of information, which is absolutely essential for graph queries. But you're able to do this, and you're able to chain it as well because you're using the database as a value. With these DB snapshots, you can very efficiently actually say, here's one part of my algorithm, and I actually then want to do a bit of closure, and then here's the next data log query, and you can do that very efficiently because it's all sort of close. If you're running your code with Crux close to it, then you can, as an embedded library, then you're able to very quickly traverse a graph without having huge sort of n+1 lookup problems, which is valuable. So anyway, that's one example, finding role user for a particular group. Here we have one finding all groups and roles for a user. So it's extending this one, which is just the roles. Now we're finding all groups as well. So yeah, you can see it's getting some more data out there. And here now we're actually abstracting some of this. So we're repeating ourselves a bit here. We have some of the clauses are exactly the same. So why not lift that out, brigade it into a rule? So a rule allows you to have that reuse across data log queries, very valuable. And then you can use that in your queries just by specifying rules. I'm pointing it to this definition here. And now my previous queries are a lot easier to write. And then this final example is quite interesting as well because we have aggregation in Crux, and it's quite a powerful aggregation model because the select, so instead of find, you have this aggregation keyword, and then you're essentially building reducers over the result set that return. And so here we're counting the number of the number of common groups based on shared roles. So this right now just returns one group because there's only one group that is shared as well as roles by user 1 and user 2. And then there's some example that says, you know, if you want to extend this just to prove it to yourself, what happens if I do put them in more groups that are shared, you can run that. So we could look at that. But again, in the interest of time, we'll skip through to another example. So this happened 4 days ago. Someone on the Crux closure in Slack said something about wanting to use pull syntax. We don't have a pull syntax right now, but someone else said, oh, you can use Pathan to do that. I know nothing about Pathan. I looked at the README and I clicked away quickly because I had things to do. But someone then took that. A few days later, they built this graph demo. And it's actually quite a neat little demo. I don't fully understand it, but it's using the Entity API and they're using it to build this nice little interface here. So we can have a quick play with that. I can share these links for you. Obviously, they're all public. So I think it's, which one is it? This one. Yeah, so here we are. I do a search for the entity, or the entity with the ID Jeremy. Equally, if I type in Håkan there and submit, I get back his friend list, and then I can navigate through the graph. So I can see that he's friends with me, I'm friends with John, John's friends with Malcolm and me, but he's not friends with Håkan, or he doesn't feel mutual about that. And then I can go back to me, I'm friends with everyone, who haven't I clicked on? Anyway, so you can navigate around the graph, but it's quite a nice little example, and the user interface is completely declarative in the way it's been defined, and I think it uses Fulcro or something under the hood. But it's quite nice, and it's a nice sort of illustration of how quickly you can build things that are useful, well, for some measure of useful. So anyway, shout out to Sunzo for doing that. So there is another example. So what we've been working on is a console, which I will just go to here and close this thing and then start this thing because I use the same port. I couldn't figure out how to change it. But essentially we have a console which it's work in progress, early days, but we think that Crux will become more clear, like instantly, like, oh yes, this is clearly what I need in my life, because the ability to convey the importance of bitemporality and graph queries is really valuable. And we know just from a development point of view, just having easy access to your data, so you can see kind of what the schema would look like, or if you want to enforce a schema, you can build things on top of that console to make that job easier. You can do that maintenance more easily. But also, when you put your database in production, when Crux is in production, you want to know, how many records are in there and like how big are the indexes and that sort of thing. So we're very conscious of that, and we're building things to make that easier. So if I go back to here and refresh, I need to, oh, right. So I said to Dominic, who built Edge this morning, how do I make it go automatically? So I need to figure that out. But anyway, so it's going to take a moment to run. But in the meantime, I'll show you the online example. So if you now will go to juxt.club, that's literally just juxt.club. You don't have to type in www or console, it redirects. But this is like a big sandbox that we all have. So if anyone does have their laptops, we can just start transacting into this thing, which is a bit dangerous. I don't know what's in there right now. So if I run this query, I need to put this back in. If I run this query, I get some results. So what we're looking at here is a very empty database by the looks of it. So what I want you to do is to go to juxt.club. I'll do it from scratch. Juxt.club, this. And then you can basically just type in transactions in here. And then we have some samples along the bottom. So you could say this one, put, so this is how you format it. And I could say Crux, DBID, and I can put in my GitHub username, which is refset. And I can put in something like Crux night question. And I could say, I don't know, what's a good question? Is there any pizza left? That's a good question, because I didn't have any. I hope there's some left. Is there any pizza left here? Question mark, right? And we'll leave the currency in there because why not? Right, so anyway, so if I submit that, I Control Enter or press the run button, it's submitted that, and then I can immediately go back to my query with full results and run that and see I have actually made a transaction to the database, and it's unifying across all the entities in that database. So if other people start putting things in there with random keywords, this table is going to grow bigger and bigger and bigger, which is great because then we can see where the holes are and what the schema looks like. And of course, we can view this in Eden or table results. And you'll notice on the bottom left, we also have the ability to view things in valid time or transaction time. So we've just done an insertion. So now I would guess if we click on that time, I don't know what time the server is. It's a good question. But if I put it in at like 1800 for transaction time and run it, I reckon that won't return. Maybe it is behind. Okay, okay, there was loads of stuff in the database. It's been deleted. So there you go. So so that's how the console works. And hopefully this other thing is loaded now, so I can refresh that. Great. So this is the local development version of the console. Obviously, we're not expecting people to administer their Crux databases using a hosted version of the console. So the idea would be you should be able to do npm install Crux, and then have a nice standalone Crux server, as well as a console that all this is going over cores. So we have a closure script client, not formally released. It's not in the repo yet, but we're working on it. And this is how this is working. Going over cores, and then you can access anything that might be in a cluster of machines, or maybe you have a development machine or a production machine. So that's good. But yeah, this is built in reframe. And I think it's product. Yeah, this is reframe. So somehow I make Control H. There you go. So yeah, so if I do submit a transaction, you can see how it's all working. And you may have noticed as well, as I was typing like a thing, it's suggesting common things that might be useful in data log, but it's also pulling stuff out of the database, and that's by virtue of the fact that there is actually a way to say, well, what are the known attributes in my database, and it's pulling that out into here somewhere, metastats. Yeah, so it's pulling out and it's counting the number of attributes that are known. So that's how that works. So yeah, this is very much work in progress, but we're excited about continuing to work on that and develop that for a long time. So that's good. And there's some links to the documentation. So that was kind of it. I think I showed you everything I wanted to. So if I just go back to this, we now have a bit of time. So it was supposed to finish at 8:30, wasn't it? I can't. Does anyone know what time it's supposed to? Oh, I'm happy to stay. Yeah. So again, opportunity. We can just pause if people want to socialize and chat for like maybe 10 minutes. Get on your laptops, and then in about 10 minutes' time, we'll reconvene for a little panel. We have these questions about event sourcing and is the transaction log stable? So rejoin us and we'll talk about that. But yeah, if you need some links, I can help you. Hi. Okay, sure. Yeah. So if you need any links, I'll put them on. I'll put them up now. Yep. Yeah. 8:25. Yeah. Great. Thank you.